Find the curvature of r of t is t squared ln of t and t times ln of t at the point 1, 0, 0. We can assume that t equals 1 because if we plug it in, we'll end up getting the point that we got. So t squared would be 1 squared, which is 1, and the ln of 1 would be 0, and then ln of 0 again times 1 would still be 0. So we get the point 1, 0, 0. So curvature is given by finding the derivative, first derivative, crossing the second derivative, finding that magnitude, all divided by the first derivative's magnitude cubed. So to start off, we're going to find the first derivative. Super simple. We get 2t, 1 over t, and then we get the ln of t plus 1. Now we need to find its magnitude. So the magnitude of RT is just all of that squared and then square rooted. We end up getting, after we square everything out, get 4t squared plus 1 over t squared plus ln t plus 1 squared, which is a polynomial, which we will now factor. We end up getting, after factoring, same in the beginning, so by factoring out we get ln squared t plus 2 ln t plus 1. We can go ahead and plug in 1 for t because we know that t equals 1. Just to make our life simpler and so that we get a number rather than an equation. So plugging in 1 for t, we get still in the square root, by the way. We get 4 plus 1 plus 0 plus 0 plus 1, or the square root of 6. So now we need to find the second derivative. And the second derivative is just taking the first derivative and just deriving it, which again is pretty simple. So we go ahead, we have 2t becomes just 2. We have 1 over t, which just becomes t minus 2. Then we have the ln of t, which is just 1 over t, and then the derivative of 1 is 0, so we don't include it. Now we're going to go ahead and take the cross of r, the first derivative of r and the second derivative of r. And what we're going to get, oh, I forgot a minus sign over here, by the way. And what we're going to get is a lot of work. So we're going to come here, and we're going to have I, J, K. We're going to have 2t, t to the negative first, ln t plus 1. And then t, and for a second derivative, we have 2 minus t to the second, negative second, t to the negative first. Go ahead and cross it. After crossing, we end up getting t to the negative 2 ln t plus 2 I plus 2 ln t j minus 4t to the negative 1 k. Now we need to find its magnitude, so again, define r cross t, or r, the first derivative of r, cross the second derivative. We're just going to go ahead and take the magnitude, so we're going to go ahead and do t minus 1 ln t plus 2 the whole square plus 2 ln t squared plus 4 minus t to the negative first squared, and we end up getting t minus 4 ln 2t plus 4 ln t plus 4. That was our polynomial that we had. Plus 4 ln squared t plus 16 t to the negative second. Again, we can come in and plug in 1 for t to make our lives easier. And we end up getting 1, 0 times 0 plus 0 plus 4 plus 0 plus 16 all under square root, which gives us 20. Going back to the first equation that we had, we have r t cross r double t magnitude over r t magnitude cubed. The first one is 20, and the bottom one is 6. 6 is cubed. End up getting 20, 30, 20 over 6 square root 2, or 6 square root 6, which ends up, once it's simplified, we get 10 over 6 square root of 3, which is approximately 0.3043 as our curvature.